Ever look up at the night sky and feel a sense of wonder? It's vast, it's beautiful, and it's in constant, breathtaking motion. Our Earth, our Sun, our entire Milky Way galaxy, we're all part of a grand cosmic dance, pulled and pushed by forces on an unimaginable scale. For decades, astronomers believed they had a pretty good handle on the major players in this dance, like the relentless pull of gravity. But what if there's a force pushing us away? Have scientists really found a source of anti-gravity out there in the cosmos? Let's dive into one of the biggest mysteries in the universe. To understand what's happening, we need to zoom out. Way, way out. Imagine a map of the universe, not of stars, but of entire galaxies. You'd see that they aren't scattered randomly. They're clumped together in massive structures called galaxy clusters, and even bigger ones called super. These are the cosmic heavyweights, containing thousands of galaxies, all bound together by their immense collective gravity. For a long time, scientists thought the primary force tugging on our corner of the universe was a structure called the Great Attractor. As the name suggests, it's a gravitational anomaly, a region of space with so much mass that it's pulling our Milky Way and countless other galaxies toward it at incredible speeds. But science is all about testing ideas, and as our technology improved, astronomers started to notice something wasn't quite right. The Great Attractor was massive, for sure, but was it massive enough to explain the full speed of our journey through space? The numbers just weren't adding up. There had to be something else out there, another major influence that we were missing. The search was on for this mysterious cosmic player. The breakthrough came when scientists turned their attention in the opposite direction. If we're being pulled from one side, could we also be getting a push from the other? That's when they focused on a region of space that seemed surprisingly empty, an area with far fewer galaxies than average, a cosmic void. This led to a fascinating hypothesis. Maybe it's not just about the pull of massive structures, but also the push from empty ones. Think of it like a cork in water. It's not just being pulled down by gravity, it's also being pushed up by the surrounding water. In the same way, our galaxy might be pushed away from this void, adding to the pull from the Great Attractor. This idea became known as the dipole-repeller model. This concept was a game-changer. It suggested that the motion of galaxies isn't just a simple story of gravitational attraction. It's a cosmic tug-of-war, with both dense superclusters pulling us in and vast voids pushing us away. This push is untrue anti-gravity, in the science fiction sense. It's still a consequence of gravity, or rather, the lack of it. A region with less mass exerts a weaker gravitational pull, so we effectively get repelled from it, as we're pulled more strongly by denser regions. So, where does the Shapley supercluster fit into all this? Located about 650 million light-years away, the Shapley supercluster is the most massive concentration of galaxies in our local universe. It's an absolute behemoth, a true cosmic titan. For a while, astronomers thought that the combined pull of the Great Attractor and the Shapley supercluster might finally solve the puzzle of our cosmic motion. It was a strong candidate for the ultimate destination of our galactic journey. However, even the colossal Shapley supercluster wasn't enough. When scientists did the math, meticulously calculating the mass of all the visible galaxies within it, they once again found a discrepancy. The gravitational pull from Shapley, while enormous, still couldn't fully account for the speed at which we and our neighboring galaxies are hurtling through space. There was a missing piece, an unknown factor that was contributing to our velocity. The universe, it seemed, still had more secrets to reveal. The mystery deepened. We had a pull from the Great Attractor, a push from the dipole repeller, and another massive pull from the Shapley super. Yet, our motion was still faster than all these combined forces could explain. This pointed to an even larger, more distant structure, something so massive its influence could be felt across hundreds of millions of light-years. The hunt for this ultimate cosmic driver was on, and it would require us to map the universe on an even grander scale than ever before. And in 2017, a team of astronomers announced a stunning discovery. They had identified a new, vast structure that seemed to be the missing piece of the puzzle. This wasn't just a single supercluster, but a complex network of superclusters stretching across an incredible distance of 100 million light-years. This newly found concentration of mass, combined with the push from the dipole repeller, seemed to finally provide the force needed to explain our galaxy's peculiar motion. So, while it's not anti-gravity in the sense of a repulsive force, it is the discovery of a massive cosmic void that effectively pushes us away, working in tandem with the immense pull of distant superclusters. To truly grasp this, we need to understand our own cosmic address. In 2014, scientists fully mapped our home supercluster and gave it a beautiful name, Laniakea, which means immeasurable heaven in Hawaiian. Laniakea is a staggering 520 million light-years in diameter and contains about 100,000 galaxies, including our own Milky Way. Mapping it revealed that structures like the Great Attractor are not isolated objects but are central hubs within this vast supercluster. Laniakea itself is like a watershed, with all the galaxies within it flowing toward a common gravitational center. But here's the challenge. Mapping these colossal structures is incredibly difficult. One of the biggest obstacles is, ironically, our own galaxy. The Milky Way's disk, filled with stars, gas, and dust, creates a zone of avoidance that blocks our view of about 20% of the distant universe. It's like trying to map a forest while standing behind a giant tree. Astronomers have to use clever techniques, observing in wavelengths like infrared and radio that can pierce through the dust, but it's still a major hurdle. This obstruction complicates our ability to get a complete picture of the mass distribution in our cosmic neighborhood, making it tough to precisely calculate all the gravitational forces at play. So, have we found a source of antigravity? The answer is a nuanced yes and no. We haven't found a new fundamental force that repels matter, but we have discovered that the structure of the universe itself, with its massive superclusters and equally vast voids, creates a dynamic of push and pull that drives the motion of galaxies. The push from the dipole repeller is just as important as the pull from the Shapley supercluster. What this incredible journey of discovery shows us is that the universe is far more complex and interconnected than we ever imagined. Our motion through space is undetermined by a single object but by the intricate gravitational web woven by thousands of galaxies across billions of light-years. Every new map we create, every distant structure we identify, brings us one step closer to understanding our true place in this cosmic dance. The story is far from over, and the secrets hidden behind the veil of our own galaxy still await discovery. Thank you so much for joining me on this cosmic exploration. It's a reminder that there's always something new and amazing to learn about our universe. If you enjoyed this journey and want to explore more mysteries of science and space, please hit that like button and subscribe to the channel. It really helps us bring more content like this to you. See you in the next video.